So now it's recording. Okay, so we're on page 13. Here are the answers. See if you can do that by yourself at home. And these are the ratios. We're going on to page 14 and we have worked ahead. So everybody in class has some answers. So these are the same ratios: cats to dog, 4 to 3, 8 to 6. And we're talking about equivalent ratios. And remember the word bank in the beginning. What does equivalent ratios say in there? Can you guys go back to the very first page on the cover?
Equal says two equal quantities per fraction.
They're equal. The amount is the same, but they might be different fractions, but the value is the same. Are you following? Equivalent, right? So now let's look here. One way to show equivalent ratio is with an arrow diagram. So what goes in the multiplication part here? 4 to 3 turns into 8 to 6. What's our multiplier?
2.
So the 2 goes right here. That's called a multiplier. To find equivalent ratios, we multiply. The multiplier is 2, okay? And so here are from a previous page, Sienna earned $32 for every 4 hours of babysitting. Here are some ratios you wrote earlier: dollars to hours, 32 to 4, 64 to 8, and so on and so forth. Now your job is to find the multiplier from 8 to 1 to 32 to 4. What's our multiplier? Times 4, both numbers times 4. Do we need a calculator today, guys? Feel free to grab one, because this lesson is not on knowing how to add, subtract, multiply, and divide in your head. It's about speed. But always try the easier problems in your head. Like 8 times 4 is something you need to do in your head. But when it gets harder, you can use a calculator. Okay? Very good. Next one. What's our multiplier here? Abby, tell me your answer.
2.
Abby, from 64 to, whoa, what's our multiplier?
It's not a multiplier.
Do you have a number in there, Abby?
I had 2.
So, but if you multiply times 2, wouldn't be 64 times 2 be 128?
Oh.
So I got you on a little trap. So what happens here? How did we get from 64 to 32 and from 8 to 4? Anybody? Yeah, Aiden? Okay, if I divide by 2, what's our multiplier? Anybody? Let's keep it a it's division, but what am I multiplying with to get half of a number? What am I multiplying with to get half of a number?
A half?
Yeah, the multiplier is actually 1/2. So dividing by 2 means multiply by 1/2. And since they're asking for multipliers, we're going to make it that. Whoa, what about 16 to 40 and 2 to 5? How did we multiply here? How can we? 2.5. How did we get that? Anybody?
I did 40 divided by 16.
Oh, you did. Jocelyn did 40 divided by 16 and she got the multiplier, because the division is the opposite of multiplying. So you can always do that to find the multiplier. And it's 2.5 or 2.5. By the way, notice I have an X here. When we get into math more heavily, like algebra, this X does not mean multiplying. It means an unknown number, a variable. So for the purpose of this exercise, I'm going to write X like for times, but not in the future. We don't want to use X for time. If I correct you, it's because we're transitioning into algebra, where X is a variable, like an unknown number, okay? 3 to 5, is that equivalent to 12, from 12 to 13? What do you guys think? 3 to 5.
It's the closest. It's times, no, it's not, because one's times 4 and the other one's times 6.
Ah, one is times 4 and one is times 6. So that doesn't work, right? Not equivalent. Very good. How about from 8 to 24? Is that the same as from 5 to
Yes, and
15?
above times 3.
Both are multiplied by 3, and that is true proportion equivalent. Very good, guys. How about from 8 to 6 and 12 to 9?
Now 8 to 6.
And 12 to 9. Now it's written different. Notice? It's got a different layout. See if we can do the same thing. I'm just going to write it the way that we had, just to get an idea when I look at the numbers.
They're both plus 3.
Oh, but we are from 8 to 12. What are we multiplying with? Remember what Jocelyn did? She divided to find the multiplier.
1.5.
1.5. And how about 6 to 9?
That's times
6.
1.5.
It's also 1.5. You can do 9 divided by 6, and that will give you the multiplier. And these are equivalent then. I'm going to show you another way that you can tell if they're equivalent. Are you ready? This is a different shortcut way. Are you ready, everybody? So 8 to 6 is a fraction, 8 over 6. And we want to know if that equals 12 over 9. So what's called the cross product. You multiply across. Use arrows to guide you. You're multiplying. And if the numbers, the answers match, it's true. So what's 6 times 12? 6 times 12. What is this? Huh?
72.
72. And then what's the other one? 8 times 9?
72.
8 times 9 cross multiplying is 72. If the two numbers match, you got a true proportion. If they don't match, you do not. Does that make sense? Okay. Everybody, these are notes. Let's write it on top. And the previous page. Oh, oops, somebody's here. My thing is frozen. So these are notes. There it is. It's Leona, isn't it? Yeah. Well, guys, any other idea how we can get from 1 to 3 and from 5 to 15? Multiplying by 3. I know another way. Look at this group of numbers right here, the 4 I'm circling. Yeah, what by what? And what's the constant multiplier? We could do that. So, but what's the constant multiplier if I go from 30 to 15 and from 6 to 3? No, that's when you divide by 2, right? What's the multiplier? Remember, we want yeah. The constant multiplier means the same number you multiply with, it would be 1/2, right? You're multiplying by 1/2 to get, you could multiply 6 to 30 by 1/2. That is the same as dividing by 2. And you could also use, or, I heard the word, use cross product. That's when you check. Let's try that one more time. You can pick any 4. Let's do 5 over 1 is equal to 15 over 3. So you can pick any 4 and make it a cross. See if that works out, that the numbers are the same. So you draw your little arrows to indicate that you got to multiply across. 3 times 5 is, and 1 times 15 is, and since they both match, we got the right ratio. The cross product helps you determine if you've done it right. Okay, so now look at number 3, use the table above. Choose 2 different pairs of entries and form ratios. Find the multiplier for each pair of ratios that can be used to justify that they're equivalent. So pick any 2 pairs up here.
What about the 36 and 24?
This here, 30 to 6. And the other one, which one? 20 to 4?
Yeah.
Ooh, that's a good one because these are not easy to find, right? What's our multiplier? To get from 30 to 20, are we multiplying or by a number bigger than 1 or less than 1? Are we dividing? That's the question. When we divide, our multiplier is a fraction. That's a good one. Remember how you found the multiplier earlier?
They're both times by 1.5.
1.5? You sure?
Yes. The math on the calculator.
1.5? 30? 30 times 1/2 is 20? Try it. 30 times 0.5? I don't think it's 20. Try it, guys.
30 times. See, I did the 30 divided by 20, and then the 6 divided by 4.
Oh, because you did it the opposite. You need to do 20 divided by 30 because your multiplier is going to be less than 1.
It's 0.6.
Because 666 repeating, right? 0.666 is 2/3. Did you guys know that? 2/3. So if your answer is 0.66 repeating, is the same as 2/3. So your multiplier is 2/3. Try the 6 and the 4. Divide 4 divided by 6 and see if you get 666. See how it's the same 2/3. So listen, when the number gets smaller, you're multiplying by a fraction less than 1. If the number gets bigger, the answer gets bigger, you're going to multiply, your answer, the multiplier is bigger than 1. Are you following? Kind of? Okay, one more. Let's try one more. This was a good one because it made us think, what's that multiplier? Why did I not go? The multiplier is 0.66. Why did I not say, oh, I'll just use 0.66 and round it to 0.67? Why did I not do that? I can, but why not? What's the reason I changed it to the fraction form and not the decimal form? Which is more accurate, the fraction or the decimal? Because what did I do with the decimal here? Remember how many 6s you saw in the calculator? What happened? Did I round or did I not round?
You didn't round.
I did round because I took the last few 6s and added 1 here, rounded up. Is that accurate?
Yes.
Is rounding really the same as the original number? Or
No.
did I lose some values?
Lost value.
If you lose values, it's not as accurate as the fraction. The fraction is always more accurate. Do me a favor. In your calculator, do 2 divided by 3 and see what you get. 66666. You see, who wants to mess with all those 6s? 2/3 is so much easier. What would 1/3 look like as a decimal? If 2/3 looks like 0.66666 continue forever, what would 1/3? 3333333 is 1/3. It keeps going. So just to give you an idea, when you see those numbers, use the fraction. How about 1/5? What would that look like?
0.2
No.
0.2.5.
It's actually 0.2. So that is a ending decimal. 0.2 is the same as 1/5. That actually ends. But I want you to recognize certain decimals and then know what the fraction is. Okay, one more pair from above here. Give me one more pair that we can compare and find the multiplier.
The 5 to 1.
They don't have to be next to each other, by the
5
way.
to 1 and 60 to 12.
5 to 1. Oh, I need to do it differently. We're going to write it like that. 5 to 1. Like that.
60 to 12.
60 to 12.
Times 12.
So what's our multiplier here,
Times
guys?
12.
How do you figure that? How do you
Because
figure 12?
5 times 12 is 60.
Yeah, but
and
what
1
is
times
if,
12 is 12.
exactly, but what is if you don't know that 5 times 12 is 60? How can you find that number without going, oh my gosh, I have no connection in my head? What do you, divide what?
60 divided by 5.
Try 60 divided by 5 and see if you find that multiplier. You got it? You see how you can do that? Then you don't have to rack your brain, right?
Also 60 divided by 12 is 5.
There you go. See how those numbers
Just
are all
check it.
connected?
60 divided by
Yeah.
12 is also 5.
Yeah. Very good. So now suppose you know here there are less than 20 fish in the lab and the science teacher adds a new frog to the animals already in the lab. Oh my gosh, now they're throwing all that at us. Make a table that shows possible numbers of fish and frogs in the lab after adding the new frog. Does it say we have to keep the same ratio?
No.
Does it say anywhere we should, though, huh? Suppose you know there are less than 20 fish in the lab. Let's make a table sideways because we already have more space sideways. So I'm going to start here. So put that down here. Big rectangle, and then we're going to make a horizontal line in the middle. What quantity should we put on top? Fish or?
She's on top.
Fish and frogs. Remember, we have less than 20 fish. So let's find some combinations. What are some combinations? Look up at your table up there. Less than 20. So 15 and 3. I'm looking at up here. How about we have less than 20, so let's do 16. 16. Let's do one frog. No, wait. 5 to 1. We can't have.
You can wait. Can't you do
5 to 1.
4 to 16?
4 fish to, no, 4 frogs to 16 fish?
No, 16 fish to 4 frogs.
But what would that be? The multiplier is
4.
So you're saying 16 to 4?
No.
Huh, I'm not sure about that. Hang on.
4 times 4 is 16.
Yeah, but then we need to have the same in the others. 3 times 4 is not 15. Don't match. You see? If we have 4 frogs, we have 20 fish. Because that number is already up here. But we have less than 20 fish. So we can't have 20 fish, right? That we know there's less than 20 fish in the lab. So we don't know how many. Let's keep 15, it's our last 15. How about, let's think of a number of fish.
Three fish.
No, because then we won't have any frogs, because if you take 3 fish, it's 5 to 1, so you wouldn't have any frogs.
Oh, so you can do a half a frog.
You can't have half a frog. I'm not sure where this is heading.
Part of the legs too.
Let's add a frog to this number 15, this one here. Let's add a frog here and make that 4 frogs now. How many fish would we have?
4 frogs.
If we have 4 frogs, we need 20 fish. I don't know why this exercise is not clicking with me. I think that's what they want, 4 frogs to 20 fish. Then if he adds 1 frog, he has to add 5 more fish. That's what it is. Let's write that down. If he adds 1 more frog, he has to add 5 more fish, because each frog has 5 fish to it, yeah? To keep the ratio the same. I think that's what they want to hear. All right, this page was notes. Okay. And I believe the next page, if we go to page 17, is homework. It's a practice page. Okay, you're going to fill in this table right here with a ratio.
That's the last page.
It is?
Yeah.
Cool, we're done. Listen, we have more though. Okay, you're going to get this big square puzzle. I'm going to have to print it out and cut it up for you, but you will get that. And I have to give everybody an envelope and you can put it together. You have it where? No, you don't. It's a blank page.
Oh.
They expect you to put the puzzle together on that blank page, but I always give you a cardstock paper where you can paste it on, and then I hang it up in the classroom. This right here, we're going to skip, so you can put skip and cross it out. These are kind of cool though, I like those, but posters work in a group setting and we don't have that anymore. Vocabulary is definitely homework. Make sure you fill it in.
Can we do that today, actually?
Hmm?
Can we do that today?
Yep. Your vocabulary comes from this section or from the first page. Here are the words. You kind of have to read the description and think, oh, that's what the question was asking. Well, those are the words that go in there. And I think that's it. Sometimes I see another page I really like, but these are all, yep, that's it. Very well. Now let's stop recording and you